So for those of us who were telling me that they couldn't see the writing, this video is filmed with my phone, so I'm hoping that it may be a bit clearer because it's way easier for me to upload using my phone because it's 3G. Anyway, back to the math, or to the math. So we just finished a little mini unit on transformations and we're moving into shapes again, so just basic geometry, not coordinate geometry. And we had already visited this before the state test. Now we're coming back to it. And these are 8th grade standards. So the one that we're addressing today is Pythagorean theorem. The reason it's called the Pythagorean theorem is because there was this Greek philosopher, scientist, mathematician guy. You can Google him. His name was Pythagoras. And he came up with this theorem for right triangles. And his theorem says that if you have a right triangle, if you take one of the legs and square it, so you multiply the length by itself, and then you take the other leg and square it, if you add those two squares of the legs, a squared plus b squared, together, you're going to get the square of the hypotenuse. So the vocabulary words that we have to be familiar with is leg and hypotenuse for this situation. The legs are the two sides that form a right angle. So you're going to remember them because they're going to be attached to the right angle box. You're going to know they're perpendicular because it showed right here. And then across from that right angle box, like if I was sitting over here and I was looking up, I will get the hypotenuse. The hypotenuse is what we would call the slanty side. It's also the longest. Okay, so the hypotenuse is the longest side of a triangle. It's always going to be your C because it's the longest side. The A and the B are interchangeable. So one of you could say, I like this to be my A, so this would be my B. Somebody else could be like, no, I like this to be my B, so this is going to be my A. So if I were to go ahead and say, okay, that side is 3, this side is 4, what the heck is that side? I could figure out the length of the hypotenuse by using the Pythagorean theorem. So I'm going to make 3 my A. Someone else could choose to do B. I'm going to make 4 my B. Again, someone could choose to do my A. But everybody's going to make X C because your hypotenuse is always your C. If we rewrite the Pythagorean theorem, and then we use the value of A and the value of B to substitute, basically now we're solving for C. If you need a calculator, rock on and use one. When you go ahead and simplify 9 plus 16, 25. And then this reintroduces the whole idea of solving squared equations, which we learned in Unit 2. And because this is a square, we're going to do the inverse to isolate the variable, and the inverse of squaring is square rooting. So we're going to take the square root of both sides, and we're going to end up that C has a value of 5 units. Beautiful. So again, the only thing you have to remember for the Pythagorean theorem is that a squared plus b squared equals c squared. You also have to remember that C is always your hypotenuse, it's always your slanty side. So I'll model this one with you, and then you can pause your video and try the rest. So in this case, my directions tell me to round to the nearest tenth. So if I needed to, I would round to the tenths. I'm going to make this my B this time, and this my A. And I'm going to remember that the slanty side is always my C. I rewrite the formula. I plug in 6 squared plus 8 squared, C squared, 36 plus 48. Oops, definitely not 48, 64 equals C squared. 100 equals C squared. Another easy one. I don't even need my calculator for this one. And so then it tells me that my X, or my hypotenuse, is 10 inches. Remember, a really good way to check this is that you know that your slanty side, your hypotenuse, has to be the longest measurement. So because it has to be the longest measurement, if you got some number that's smaller than 8, you know that something's wrong. Because 8 can't be longer than your hypotenuse. Your hypotenuse is always going to be your longest side. The other thing that I just want to point out to you guys is we've been doing the triangle inequality theorems. It applies here. Like 8 plus 6 is 14. Well, 14 is bigger than 10. It's a triangle. Right? 8 plus 6, 14. The sum of the two smaller sides have to be larger than the longest side. Beautiful. So go ahead and pause your video if you want to practice the rest, and then you're going to unpause it because on the next slide you're going to have the x where it's not going to be isolated. It's not going to be your longest side. So if you want to pause it right now, I'm just going to go ahead and rock the rest of these. Calculador. I get 9.2. And again, the square root of 85 is an irrational number, so it goes on for like ever. But if I were to round that 9.219544 to the nearest 10, I would get 9.2. So if I went too fast there, I plugged 5 in for A and 12 in for B. Squared 5 got 25, squared 12 got 144. Added them together, 169, the square root of 169 is 13. Notice that certain right triangles have what we call Pythagorean triplets. And one of them is 5, 12, 13. So if you see 5 and 12 on a right triangle, you know that that final hypotenuse side is 13. And the other one is 3, 4, 5, or ratios of 3, 4, 5. So that would be like, in this case, 6, 8, 10. 6, 8, 10 is 2 times 3, 4, 5. And if you have no idea what I just said, ignore me, maybe. Last one. Oh, this is going to be another ugly square root. So I'm just checking, it's bigger than 10. It's slightly bigger than 10, but it certainly is bigger. So I just want to model for you what happens when you're not finding the length of your hypotenuse, when you're finding a length of one of your sides. So if you check out the triangles on this slide, you'll notice that you have a measurement for your hypotenuse, and what you're trying to find in this case is one of the sides. You're going to still use the same exact formula. The Pythagorean theorem doesn't change, but you're just going to have to do a little more isolating the variable, more steps to isolate your variable. You're still allowed to label either of your legs A or B. And then when you go to solve it, and you're going to have to do a little more isolating, like I said. When you end up squaring both of your sides and your hypotenuse, you're going to come to a situation where you're going to have to solve. You're going to have to isolate the x squared first, since the inverse operation of plus 36 would be minus 36. Right? You're just going to have to make sure that you minus that 36 from 144 before you take the square root. And then you continue to isolate the variable by doing the inverse operation of squaring, which is square rooting. And because, again, it tells me to round to the nearest tenth, it would be 10.4. And even though it doesn't look like this triangle has one of its legs is 10.4 inches and the other is 6 inches, the beauty of it is I know that 10.4 has to be less than 12 because my hypotenuse has to be the longest side. So if you need to see another one modeled, go right ahead. I'm just going to do a couple of more for you. So if you want to pause it and try, that's awesome. And if not, that's your choice. I put the x as the b in this case just to show you the difference of if I decided to place the x as the a as opposed to the x as the b. It doesn't matter, but I'm just showing you the steps in case you need them, in case it may look different to you or you're not quite sure how to solve it if the x is with the b. Again, you can choose to always put the x as the a, so the x is the first term in your equation. Positive 49, so I'm going to go ahead, because it's a positive 49, I'm going to subtract 49. This minus sign has absolutely nothing to do with the fact that I'm adding x squared. That plus sign has to do with the x squared. The minus sign has to do with the fact that it's a positive 49. So again, my x ends up being 24 after I take the square root of both sides. My x becomes 24, and that's great because my hypotenuse is 25, so that's still smaller than it. I'm going to do one more for you. I'm just going to do a reasonableness check. Yeah, 8.7 smaller than 10. 8.7 plus 5 is 13.7, bigger than 10. It's a triangle, it's a right triangle. In closing, the two things that you have to remember is the Pythagorean theorem only works for right triangles. So you can't just see a triangle and be like, yeah, I'm going to use the Pythagorean theorem. No, it only works for right triangles. The other thing that you have to remember is that the hypotenuse is always your C value. It's always the longest side. So it's always going to be on the right side of the equal sign. It's always going to be that term that's by itself. A squared plus b squared equals c squared.